Okay, you can happily ignore this video altogether. I'm sure you can. I'm going to go over it because the question was sort of asked in a lesson, and it really has to do with these. They're not A and not B, and the fact that it's an algebra. So, like I said, you can ignore this one because it's mathematical. I've scoured all the A-level books and it doesn't really cover this, but I wouldn't be surprised if it just popped its little ugly head up at some point. So let's go to maths, and we know that if we have, let's say, 3, 2 plus 5, and we expand those brackets, then really what we're saying is we're multiplying everything on the outside by what's on the inside. So I would have 3 times 2 plus 3 times 5 to get the correct result. Okay, and that result there is 21. I could have done it by adding these two together, so I've got 3, 5 plus 2 is 7, 3 times 7 is 21, just to prove that that works. Now we had in our Boolean algebra this sort of thing, Q equals, and I'm going to do the AND version, I'll do the OR version as well, not A and not B, and it really looks a lot like this one here, okay, where I've got the symbol, so that could be the not symbol, and then my variable A and B, and you might be led to believe that you could just do not A and B by removing the not from each one and or factorizing and putting it on the outside, and the same would go for the OR statement. Q equals not A or not B. Try to factorize that by putting in brackets, and you get not A or B. However, in Boolean algebra, that is not correct. Okay, we can't do that. It gives us a different answer, and I'm going to go through what that is now. So let's take a look. Let's go back to just A and B. So if I have the truth table for A and B, so this is just going to be A and B, 0, 1, 0, 1, 0, 0, 1, 1. Then I get 0, 0, 0, 1 for A and B. Let's do A or B. So the truth table for these two, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 1, 1. Now let's think about this very carefully, because if I've got this version here, my item in brackets, I am equating or finding a solution to A and B, rather like I did there. 2 plus 5 is 7. So I am working whatever is in the brackets out, and then I am knotting the result, whereas I worked everything out in the brackets here and then multiplied by what was on the outside. So let me just do that. So if I apply a not here, so in other words I'm doing not Q, and the same here, not Q, the values that I get, well, the values that I get, let's not the Q, I get a 1, a 1, a 1 and a 0. So I'm knotting the result. And again here I get a 1, a 0, a 0 and a 0. Now this is what I meant at the very start, where you could find out exactly what these are by looking at the truth tables. So I'm looking now for a truth table that has 3 1s to begin with and a 0. So I'm going to go to my AND truth tables, and I'm going to look through each and every one for this pattern here. 1110, it's not there. 111, it's not there. 1110, it's not there. 1110, it's not there. These, and if we take a look at this one in particular, if I just put the knot on the outside and put brackets in, that's not the truth table that I'm getting here. Let's take a look at the OR one. And actually I've got this value here, 1110, and that was when I did not A or not B. So that's interesting. Let's take a look at the OR one. Let's go back to the AND thing. I've got this value here, here. So when I knotted my A or B, that was the same as saying not A and not B. So what I'm going to write down now is the result of that. So if I've got not A and not B, then that is the same. Okay, so as saying not A or B. So really I'm looking at that one there. So if I put the not there, I'm ending up with an AND version, and the same happens on this side. If I've got not A or not B, that is the same as saying not A and B. So let's take a look again. Which one have I got here? I've got the ANDs. So if I take a look at this one, this is not A and not B, and that is my pattern for it, 1010, but that was the same as this one here, 1010. Can we see how just moving the knot on the outside actually has switched over the operator, and we get the same on this one here. I've got my not A or not B, that has got that pattern there, 1110, but that pattern there is the same as that pattern over there if I put the knot in front of it. So it's not A and B. So well, it's rather difficult to explain, but there we have it. Sorry, this pattern here, 1110, not A or B, which is this one here, is giving me this pattern here, and that pattern there was generated by an AND. So we have a sort of tricky situation. We can't just look at moving the knot outside and using brackets. So what we're saying is that if we have Q equals not A and not B, to use brackets with A and B, we would use the opposite operator when we move the knot outside of the bracket. And the same goes the other way round. So if I've got not A or not B, if I wanted to use brackets or move the not outside of the bracket, got my A and B, I would need to use the opposite operator. Now that is something called De Morgan's laws, and I have not found that in any A-level textbook. I do know it exists at A-level in computer science, and I don't think it will be down to GCSE. So what I'm trying to say to you is never write these, okay, because they will not be the correct answers. So be very, very careful. I can't see this appearing at all in the exam. And just to sort of prove it, I've got discrete maths for computing. I'm going to open it up to this page. See if I can get it under the camera. And what we're looking at here is something called De Morgan's laws. Two important laws that we've got to use, where not P and Q is the same as not P and or not Q. In other words, we flip that and put the not inside the brackets. And the same goes the other way round. If I want not P or Q, that's the same as saying not P and not Q. So that's the laws. That was a little aside. As I said, you could ignore that video altogether. I don't think it's ever going to appear in your exam unless they're absolutely mad. But if it does, you can use truth tables, even though I made it slightly difficult going through it, to actually produce these results. So we'll move on to the next video and we'll start taking a look at what happens when we introduce the not after the